Hello all. In this video session we will be mainly discussing about function. Now function is an important component of modular programming. Now what is modular programming? So in modular programming we will be breaking large programs into smaller programs or smaller pieces of code, and these smaller pieces of code are called modules or functions. Okay. Now why are we splitting this large program into smaller pieces of code? This is to help manage complexity. Okay, since we are dividing into smaller codes, it will be more easier to read and manage. Okay, and then another advantage is reuse of the code. Since we have these small pieces of code, it can be used at other places of the program or maybe used in another programs. Then also it allows us to help independent development of code. Okay, so if we have one big program and is divided into different modules, all these modules can be developed parallelly. Error checking also can be done parallelly, and if any new modifications are required, the modification can be applied to the uh, dependent, or modification is only required to be applied on the related module. Okay, so this is another advantage. Another reason is that it provides a layer of abstraction. For example, if we have module 1 and module 2, and module 1 required to use some functionality of module 2, or any other program which requires to use the functionality of module 2, then it only required to call the function defined in the module 2. Okay, or another example if we can consider is that if we want to print something on the monitor, we can just use the printf function which is defined inside studio.h. It doesn't require to know how this function communicates with the operating system or the monitor. Okay, so this is how it provides a layer of abstraction. Okay, now we will see what functions are. Functions are building blocks of a C program. Then function is a named set of instructions to perform a particular task. Okay, so function will be having a name and it will be containing a set of instructions that is performed when that particular function is called. Okay, now functions are divided into built-in functions and user-defined functions. Now this built-in functions, now this built-in functions are predefined functions. Built-in functions or library functions are predefined functions which are already written in C. Okay, for example, our printf and scanf, then our string functions strlen, strcpy, strcat, strcmp, etc. These are all examples of built-in functions. The next one is user-defined functions, that is functions defined by the user. Okay, now for declaring or for using a user-defined functions, it has three parts. First one is function prototype or function declaration, then function definition, then function call. First we will see how we can define a function. Okay, so the syntax for defining a function is return type, function name, then inside parenthesis parameter list, open curly braces, then function body, which is a set of instructions to be executed, then close curly braces. So this return type is the value returned by the function, or return type is the type of the value returned by the function, and then parameter list will be containing the list of parameters that is actually taken by this function. Okay, and this function body is a set of instructions that is executed, then this function is called. For example, here we have a function add to numbers, and the name of function is add, and it will be taking two arguments n1 and n2. It is of type int, so we have given it as int n1 comma int n2. Then we have declared a variable sum. Sum is actually adding n1 and n2, and it is returning the value sum. Since sum is an integer value, the return type of function is int. Okay, this is how we define a function. And here this n1 and n2, or the parameters inside this function definition, is called formal parameters. Okay, now the function prototype of function declaration is similar to our function definition. Okay, so there are some scenarios where we should tell the compiler that a function such as this exists. Okay, in that cases we'll be using this type or this function declaration. Okay, the syntax is return type function name parameter list then semicolon. It is similar to the function definition, and it is, we can say that function prototype is actually function definition without its body. Okay, so there is only the function header, that is return type function name, then inside parenthesis parameter list, then semicolon. So this is the function prototype of the example that, or this is the function prototype of the add function that we have explained in the previous slide, that is this one. So this is the function definition and this is the corresponding function prototype. Okay, so this is the first line of function definition, return type int, then it is function name add, then inside parenthesis int n1 comma int n2. Okay, so we can also write it as int add int comma int, both are acceptable. Okay, so this is how we actually declare or write a function prototype. Okay, next one is function call. Syntax is function name then inside parenthesis parameters. Okay, for example, if you want to call the add function, we can just write add, then inside parenthesis num1 comma num2, and this num1 and num2 are called the actual parameters because this is the actual value that we are passing to the function. Okay, so this is a simple program to find sum of two numbers using function. Okay, so program to add two numbers using function. So we have the studio.h, then we have the function declaration, that is we have the function add, which is taking two arguments of type int and it will be returning an integer value, so here it is int. Okay, then the function definition, int add int n1 comma int n2, then into sum, then it will be adding and then returning the sum. Then we have the main function. Okay, so inside the main function there is the function call. Okay, so the program execution starts with main, and here num1 and num2 and s are declared, then two numbers are read which is stored in num1 and num2, then the add function is called. This is the function called. The arguments num1 num2 are the actual arguments, that is the actual values which is passed to the function definition. So num1 will be stored in n1, and when this function is called, num1 will be stored in n1 and num2 will be stored in n2, and then after that sum is where memory is allocated for sum, then sum is equal to n1 plus n2, so value in n1 and n2 is added and stored in sum, and this value is returned. So the control or sum values come here and it will be stored in s. Okay, then after that sum value is printed. Okay, so this is how it works, and I'm just going to run this program. So it's gcc, we have gcc and compiling and then running the program. So I'm just going to give two numbers, let's say 2 and 4, which will be giving 6. Okay, so it works. And now in this here, this function declaration is not mandatory, since function is called after function is defined. This function declaration is not mandatory. So if I don't give this function declaration, then also this particular program works. Okay, if I give 2 3, it will work. Okay, now consider the event that this function definition was after this main function. Then if the function definition was after the function call, then the chances of if we are writing the function definition after the writing the main function, then in some compilers it may show warning, in some compilers it may not show warning, but in the case of our GCC it will show warning. And warning if this particular declaration is not given. Okay, here So I just remove that statement, so it will show a warning, but it will work. It will only show a warning. I think in compilers like dev cpp it won't be showing any warning. So in these scenarios, that is, if the function is defined after it is called, then that cases we should provide the function declaration. Then the another place where we will be using function declaration is when we are defining our own header files, and inside this header file we will be declaring all the functions that are used in that particular header file. Okay, now this is another example of function, and here the program is to print a line using function, and for using printf function we have included the studio.h header file, then the function declaration void print line, open parenthesis, close parenthesis, semicolon. Here the name of the function is print line, then we are not taking any arguments, so I'm just going to give the argument or parameter list as empty. You can also give void, both are right, but I'm just going to leave it empty. Then this function is not returning any value, so the return type is given as void. Okay, this is the function definition. We have return type void, print line, function name, then inside parenthesis no parameters, so it is left empty. Then inside single curly braces, or inside curly braces, I is declared, then a plus sign is printed, then after that a minus sign is printed for about 56 times, then after that again a plus sign is printed, and then a Boolean character is printed. Okay, so this is what is written inside this function definition. And then we have main function which is calling this print line function, and then it is returning 0 value if the program is executed successfully. Okay, so when program executes, the control comes to main function, then this statement is executed, so control again goes to here, then plus is printed, minus is printed 56 times, then again plus printed, then again minus backslash n is printed, then controls comes here, and then this return 0 statement is executed, which will be returning the 0 value. Okay, now I'm just going to compile this program, that is printline.c. okay, then I am executing this program, so it will be printing one line. Okay, so if we want to print another line, I'm just going to give here print line and semicolon, then I'm going to compile this program, run the program, and it printed 2 lines. Okay, and here if you observe that here the function is defined before this is called, so this function declaration is non-mandatory. If it is not given, then also it will work. Okay, now we will see a program to find sum of first and natural numbers using function, and this is the algorithm. The function will be accepting an integer, positive integer n, and it will be outputting the sum of first natural numbers up to n. Okay, so this is our algorithm, and it will be adding up all the values up to n, starting from 1 up to n, and then the result is returned back. Okay, so I'm just going to write the program for this. First we will write the hash include studio.h, which is for the header file for printf and scanf. Then we have the function declaration, that is the sum of natnum is actually returning integer value, so here it is int, and then it is accepting, or it is taking one parameter, so it is int n, and then inside this okay, sorry, this is function declaration. So function declaration we only has these details. Okay, here this is also not required, only the type is required in function declaration. And in case of function definition, we have the same statement, that is it will be here and int n, then the function body, so we have int sum equal to 0, then I, Then for I equal to 1, I less than or equal to n plus plus I, and we will be giving sum equal to sum plus I, then finally return sum. Okay, so this is our function definition. So there is some variable for storing the sum, then I is for iterating from 1 to n. So we are iterating from 1 to n and adding all that values to sum. Okay, after calculating the sum, we are returning the sum. Okay, so this is what this function definition doing. And then our main program, so in the main, so I'm just going to give return 0, then in the num for reading the number. Okay, and now I'm just going to give printf and repositive integer, and then I'm reading it into n, so it is integer, so format specify %d, then ampersand num. Okay, I'm just going to print the sum. Printf sum is %d /n, and I am getting that value from the function sum of nat numbers of num. Okay, so this is our program. So inside the main, I have declared the variable num, then I have read value to num, and then I have called this function. So it will execute this, and then it will send result back here, and that will be substituted in this in the place of %d. Okay, I will compile this program. Okay, I'm just compiling this program. Okay, no errors. So I'm just going to run this program. Okay, first integer, let's say let's give 10, and the result is 55. If I again run it and give it, let's say 8, then 19 will be okay, then it will give 36. Okay, so this is an example for function, and here we have calculated the sum of first n natural numbers. Okay, so the next program is to find the largest between two numbers using function. Okay, so here is the algorithm written in the form of pseudocode. The input, it will be accepting two numbers n1 and n2, and it will be outputting the number which is the largest. Okay, so the function is max of n1 comma n2. N1 and n2 are the parameters. Then inside the function body, if n1 is greater than n2, then it will be returning n1. If it is false, then it will be returning n2. Okay, so I'm just going to write the program. So first, hash include studio.h, then our function declaration. Okay, function declaration, here it is returning integer value, so int, then name of the function max, then it has two integer arguments, so int comma int. Okay, then semicolon, then we have our function definition. Okay, so again int max, then int n1 comma int n2. Okay, we have to write all the arguments int n1 and int n2, and after that the function body, and inside that we'll be checking if n1 is greater than n2. If so, return n1, else return n2. Okay, you can write statements like this, or you can also write it like this. Okay, both are acceptable. Okay, so I'm just going to save this. Then we have the main program in the main. So in the main, so I have to give a return value. So program execute correctly, return 0. Then we have int num1 and num2. Then printf and two positive integer and two integers, scanf two integers, so inside format specifier 2 %d, okay, then comma ampersand num1 comma ampersand num2. Okay, so just read the value and I'm going to give the printf statement. Largest number is %d, and from where I'll be getting this value? We'll be getting the value from the function max of num1 comma num2. Okay, so this is our program. So in here, this is our function declaration, function definition, and this is our function call. Here function call is done after function definition. So this function declaration is not mandatory. Okay, now the program starts or begins from the main function, then num1 num2 declared, then value is read to num1 and num2, then this statement is executed and this function is called, and the value in num1 will be substituted to n1 and value in num2 will be substituted to variable n2. Then these two variables are compared. If n1 is greater, then n1 will be returned, otherwise n2 will be returned, and that will come here and it will be placed in the place of format specifier %d. Okay, so you will just execute this program. So we have gcc max.c -o max.out, then /max.out. So I'm just going to enter two integers 23 34. The largest number is 34. Okay, if you put \n, it will come to the new line. Okay, $, and okay, I'm just compiling it and I'm going to run it. Two numbers, let's say 24 and 12, and the largest number is 24. Okay, now if you want to find the minimum of two numbers, then just change the name of the function and here change the sign greater than to less than. Okay, then you can easily find, or you can easily write the function for finding minimum of two numbers. Okay, the next program is to find the largest number in an array using function. Okay, so we will be having a function max of array and it will be having two arguments, that is the array and its size, that is a and n. Then the output will be the largest number in the array. Okay, so here this is pseudocode of this algorithm, and it is similar to what we have learned in when we are discussing about one-dimensional array and how to find largest number in one-dimensional array. Okay, here we are just implementing it with the help of a function. Okay, I'm just going to write the code. First #include studio.h, then the function declaration, that is int, since it is returning integer value, the name of the function max of array, then the arguments, we are accepting the array and we are accepting the size n. Okay, so this is declaration, so I'm just putting semicolon here. Then after that our function definition, so function definition int, we have this and Ctrl+C, and that's, we are pasting it here. Okay, and then the function body, so that is we have int big. So initially I'm just going to assign big is equal to a of 0, that is our first element in the array. Then we will traverse through every element in the array. For that I will require a variable, let's say I. So I'm just going to give I. So for I equal to 1. Okay, we have already considered the element at index 0, so I'm just going to start from I equal to 1. Then I have to check all elements till n minus 1. Okay, so I less than n, then plus plus I. Then the condition is if the value that I am assuming big is small than or is smaller than a of I. Okay, in that case what we can do, we can just give a of I, the element at a of I is greater than the element big, then we have to substitute that value to big. Okay, so big equal to a of I, and finally we have to return the largest number. Okay, so this will be our logic, and then we have the main function. So in the main, so return 0, and we have in the array, let's say array of max, that is the max size, or just we'll give array of size. Okay, so it will be of size, and then n is for reading number of elements, and I is for iterating through the elements. So I'm just going to define max as sorry, not max, define size as, let's say, 10. Okay, so I just declared a constant size, and it is having the value 10. Okay, now printf, and the size of the array scanf, you have percentage d comma ampersand n, then end printf, and the array elements, and for reading array elements, this is a one-dimensional array, so we'll require one loop for I equal to 0 semicolon I less than semicolon plus plus I. Okay, I missed one plus. Okay, plus plus I, then scanf percentage d, then the address we are putting it, that is ampersand a of I. Okay, so this will read all the elements to the array, and then for finding out the largest element in the array, we just need to call the function max of array. So I'm just going to write printf largest element percentage d backslash n for printing a new line, then the function call, that is max of array of, we have the array arr, and then the size n. Okay, so we have passed the values, and here you can give either the value size, or we can just left it blank. This is similar to our array declaration and one-dimensional array. If it is left blank, then it is also acceptable. Okay, so I'm just going to save this program, and we will compile this program to see if there are any errors. Okay, so that is in line 39, there is an error. Okay, for I equal to 0, I less than n, so I'm just going to save it. Then we have a undeclared variable. Okay, I have declared array arr as here, so it will be arr here. Okay, so there was one mistake, so I'm just going to save this, compile it, it is okay. Okay, so I'm just going to clear it, and again I'm compiling it, and I'm going to run it, max of array.out array elements, let's say number of array size of the array is, let's say, 5. So enter the elements, there is 2 4 3 1 5. Okay, so the largest element is 5. So again I'm going to run this program, again I'm going to give 5, and I'm going to 3 4 2 1 negative, I'll give 0, and the largest element is 4. Okay, so now in this program we have found out the largest element of an array using function. The same logic is used here, the same logic that we used when we learned about one-dimensional array and how to find largest element in a one-dimensional array, and here we have just implemented that logic using functions. Okay, so here we traversed through every element in the array, and we check each element, and if it is bigger it will be substituted to the variable big, and once we have traversed through all the elements, the largest element will be stored in the variable big, and that is returned, and that will be returned when we call the function max of array comma n. Okay, now here if we observe, I have to pass here both array and n. Okay, now here n is actually a local variable. Local variable means a variable that is declared inside a block is local to that particular block. For example, any variables that are declared inside main is only accessible and alive inside this main. Okay, so this is called a local variable, and since it is a local variable, it is only accessed inside this main function. So in order to access that, I have to pass this n from here to here. Okay, so in here this main function will be having a variable n, and also this max of array function will be having the variable n, and this n will be having copy of n. Okay, so different memory locations are allocated for this memory for these variables. Okay, so if you don't want to pass this n, then one thing you can do is that you can declare the variable as global. Okay, global means a variable that is accessible throughout the program. Okay, in order to make a variable global, we have to declare that variable outside all functions. Okay, so if I declare here int n, then this n will be a global variable. Okay, there is other way you can access some variable in different functions, or you can just use this simple method of passing the value. Okay, in this method we have passed the value n. Okay, okay, now this was the logic for finding the largest number in an array, and here also if you want to find the smallest number in an array, you can just change this greater than sign to less than sign, and also you should change the name of the array which is suitable for the function it does. So min of array, something like that. Okay, try to do program related to this using functions. Okay, thank you.